On the bench today is my beloved M12 Milwaukee Screwdriver. I was using it to fix some gutters, and it took the express path back down to the ground rather than coming down the ladder with me, so ever since then it's made some interesting sounds. So I think it has some gear train issues back here. I'm hoping it's a part that can be replaced, so I'm gonna take this thing apart and see if it can be repaired. Disassembly requires T10 Torx bits. I'm actually gonna be using a security style bit just because that's what I've got in this little handy set that I like. And of course I need another driver, so the Ryobi 18 volt comes into play here. Maybe I should take the battery out too. 7 of those screws total. Unfortunately, they're all the same length, which makes it easy to keep track of. You also need to remove this clip from the bottom of the battery bay. It basically holds the plastic together right here. So make a little flat blade screwdriver and pop that out. Bend that tab up a little bit, then you can push it out. Yeah, and that happens. Separating the clamshell is actually pretty easy on this one. Just pops up, the sort of the serialized side comes off, and there you have it. And I can already see this might be what's making noise. This looks like a fan. I'm guessing that's at least related to the issue. So I'm actually gonna put the battery back in. It's not too tough to do. And then you can run it, slowly and listen really closely. This one's interesting because it makes the sound at different angles. So something's flopping around and hitting. So it may actually be coming from up here. I'm gonna first just clean this thing so I can work on it without getting filthy over and over again. A lot of people are worried about electronics getting wet, but that's not really an issue. It's more that the electronics are powered and getting wet. That's when you run into issues. As long as you dry everything out, the electronics never know that they were wet. With everything clean, I was able to see these pins, which I think hold the gear case to the motor. They're not even a press fit. You can just push on them. And I think once they pop out, we'll be able to separate the two. Pins are out, and sure enough, come apart. Now this is where things are likely to start getting kind of crazy because yeah, things like that happen. I knew something like that was probably gonna happen. I just went for it anyways, but you're gonna have lots of little parts related to the clutch mechanism. Looks like a bunch of rollers and this sort of like cammed plate. And I think on the other side are planetary gears for reduction. So all this stuff can go back together. I'm not really worried about it, but yeah, just be aware that you're gonna have lots of little parts come apart at this point. I'll also show how this goes back together later on. And now let's see if I can move it around and replicate the sounds I heard earlier. There it is. Good this way, unhappy this way. Maybe that fan is impacting something. In any case, I know now that the sound is emanating from the motor. Don't have to worry about the gear train. On the end of the motor, I cleaned up some grease and found these 2 Phillips screws on what I'll call a matching plate between the motor and the gear drive. So my plan is to take this off and keep on driving closer and closer to find the source of this movement. So I really do think it has to do with this fan in here, basically just being allowed to slide too far this way towards the gear end. And if you push the armature this way towards the, call it the electrical connection end, that's where there's no obstruction. So I think the whole thing needs to move this way. I have an idea. This is a piece of flooring. Now, why do I have this here? Well, I want something firm that I can tap the end of this armature on. See, I think that the thing that limits how far this armature can travel up towards the gear is this bearing inside. And so if I can set that back a little bit, I may be able to increase the space between the fan and whatever it's hitting. And also at the same time, if I'm hitting it downward, that may cause whatever it's hitting on the other side, which I think is the magnets that surround the armature, they may be able to slide downwards. But in any case, I'm pushing things different directions. I'm pushing the fan towards the contact end of the motor, and whatever's inside, if it's gonna move, is gonna move towards the gear end of the motor. So let's just give it a try. No rubbing noises that I can hear at any point, and no matter how I move this motor around. So that's really good. So looking through the windows on the back of the motor with a bit more light, I'm now convinced that the issue was the motor fan rubbing on some internal magnets. And as I rotate the armature while pushing and pulling it now, I can see that the fan maintains clearance from those magnets. You can also see them at the other end of the motor. I think there's 2 of them, with each one covering half of the motor case, basically. I'm not sure if they used to be attached, but what I believe happened is that when I dropped the tool, I think those magnets probably slipped down towards the electrical contact end. And so what the repair was simply to tap the motor to make them slip back towards the geared end, the output of the motor. So in hindsight, probably a better way to do this would be to use something like a socket that fits the outside diameter of the motor case and use that to tap the whole assembly without having to put any stress on the armature itself. It probably didn't hurt anything, but this would be a way to guarantee you're putting all that force right into the motor case. Here I'm using a 27 millimeter socket, or 1 1/16. And looking at the output end of the motor, it looks like the magnets have actually slipped even further and maybe even bottomed out on the end of the motor case. So that gives even more clearance between the fan and the magnets. Okay, it's time to reinstall this matching plate, but there's one thing to be aware of, and that's that it has a little notch that keys the direction of this plate. So the way you need to install that is to have the notch lined up with the terminal that has the red wire. So I'll rotate it up like this. This is the orientation you need, notch and red wire, and you'll find that the screw holes line up in that position. Okay, now it's time to reassemble the gear train, and I've got all parts separated apart here in case, like me, you took everything apart. If you didn't, maybe you can skip this section or fast forward, but I'll show you every step to get this back together, assuming you didn't take, the chuck out. So this is the clutch case on this end and the motor on this end. The parts are laid out in order. The first step is to get some grease and insert it into these holes. You want to pack these recesses with grease so that you can insert ball bearings and how the ball bearings stick. The ball bearings are going to be turned upside down with this whole case. So next would just be inserting the balls into those openings. And you can use tweezers or just drop them in and try your luck. And then go around and just double check that they're pressed down. Okay, now it's time to assemble the double reduction. So pick up this part that has sort of the 3 drive flanges on it, flip it over and drop on the 3 thick planets. You'll know you've got the right planets because the thickness of the planets is the same thickness as these pins or axles that they ride on. Next, pick up this intermediate piece that has a sun gear on one side and 3 pins on the other side and drop it into the center. Give it a rotation, it'll drop in like that. And onto that, drop the 3 thinner planets. And now you've got an assembly of all the planets. So now we're going to flip it over. Just use your finger to keep those bottom planets from falling off. And now we're going to take the ring gear cam side up and drop it on there. I'm actually going to reach around this whole assembly. You just kind of rotate the ring gear back and forth until the planets fall into there. Flip it over, set this big washer on the back. Now it's even easier to hold together. And so you've got most of the assembly held together. And this can actually come out, but the gears can't, but don't rely on that. This can easily fall off. Okay, so next we're going to take this sort of triangle or 3-sided part that has the chuck drive key in the center and put it in place. I've got the part number facing me. I don't know if that matters, but that's the way that came apart. And now in the openings between, all these openings you see here between these sort of drive flanges and the smaller ones, I'm going to put a dab of grease into each one of these. There's 6 of them. And this is going to hold on some rods in the next step. So let's put some rods into these places. Now with the 6 rods installed, we want to make sure they're all the way sort of pressed in and vertical. Next is this washer that drops on top. This whole assembly now needs to be kept in place while the clutch assembly is flipped and dropped onto here. So this is why we inserted lots of grease to hold the bearings in place earlier. What I need to worry about is getting this drive key, I'll call it, for the chuck inserted as I do this maneuver. Now I can use my finger to turn the chuck and that'll help align as I get close. But line it up as close as you can initially and then flip the clutch housing upside down. Try to just nicely insert this without disturbing too much. Flip the chuck. I wish you could have felt that like I did, but as I turned the chuck, I felt this whole assembly drop into the keyway. So now, if you're able to insert these pins on both sides, then the whole gear train is together. So without disturbing much, I'll push these pins out. And here's where the little keyed part of the matching plate comes into play. I'm looking at the little nub that sticks out on the matching plate and the slot that matches it on the gear side. I'm going to flip the motor over, kind of rotate, let it drop into the center of those planets. I'll spin it around and note that it's sitting nice and flush all the way around. It's easy to get things misaligned inside, or a ball bearing out of place, and it'll sit kind of cockeyed. If it's all the way flat, you'll be able to put in these pins no problem. So now it's reassembled. It's greasy and my workspace is dirty, but it's ready to go back into the clamshell. So I'll clean things up, come back for that step. I'm going to start with the side of the clamshell that has the light battery indicators. Turn it down. Take this little clear LED light transfer assembly, drop it in. It only goes one way. And now it's time to orient the motor. So we know it's going to fold over. We need it to fold like this. That is, red is on the back and it sits in this little opening. You see the circuit board is stepped, so it sits there. The white insulation, black wire is in front and it has a little recess that it fits into as well. I think it's probably easiest to place the circuit board first. It has a slot in the back and in the front. So circuit board in place. Good. Next, let's get the motor and gear train in place. Okay, good. You can tell that there's a slot here for the clutch selector. So that's seating in the right place. Next, we're gonna have to seat the trigger. To do that, make sure the wires are down sort of in the recesses. Yeah, it feels really solid and flat once you get it. The battery connector has a little tab on the side and a corresponding slot in the clamshell. So just insert it in there. Here's the reversing switch. The switch will have to kind of rock a little bit to make this work. Or maybe not. Pretty easy, actually. So that's everything installed on that side. Let's see if I can insert this side on now. Okay, I'm watching the reversing switch. There we go. Ooh, yeah, it's very obvious when you slide into place. So that's all good. So now I'll buzz down these 7 screws. Here's that clip that holds the bottom of the battery bay together. So it has this little kind of tab in the center that holds it in place. I'm going to bend that back down and then I'll just slide it back into place. So when it seats, that tab is retained in a little plastic slot there. It'll keep that from falling out. Okay, let's test this thing. Clockwise. Counterclockwise. Looks like this one's good to go, and this repair surely applies to any number of M12 tools that have the same kind of non-brushless motor arrangement with those magnets that are inside the motor sleeve. So if this was helpful, hit that like button. If you got any questions, throw them in the comments, and thanks for watching.